Hey everyone, welcome back to our journey into matter. So we've already covered the big three, right? Solids, liquids, and gases. We even saw how a little heat can make ice melt or water boil. But what if I told you there's a secret escape route? A way for liquids to vanish into thin air without all that drama? Well, that's what we're digging into today. So, let's start with a question. Do you really need to crank up the heat and boil water to turn it into a gas? I mean, think about it. You hang your wet clothes on a line, and a few hours later, they're dry. The water's gone, right? It's turned into a gas. But your clothes weren't boiling. So what's going on? It's not magic, I promise. That magic has a name, and it's called evaporation. And here's the cool part. It's the process of a liquid turning into a vapor at any temperature below its boiling point. That's the key. You don't need a stove, you don't need a kettle. This is happening all the time, right on the surface of puddles, lakes, and even your glass of water.
Okay, so what's the real difference between evaporation and boiling? Let's break it down. Evaporation, you see, is a surface thing. It's like only the people at the very front of the line get to leave. Boiling, on the other hand, is a full-on party throughout the entire liquid. Bubbles are forming from the bottom, the middle, everywhere. Plus, boiling happens at one specific, very hot temperature, while evaporation, it can happen at any time, even on a cool day.
So how exactly do these particles pull off this great escape? Well, picture all the little particles in a glass of water. They're all jiggling and bumping around. Some are just chilling, but others are super energetic, zipping around like crazy. If one of these high-energy particles happens to be right at the surface and it's moving fast enough, bam! It can literally break free from the pull of its friends and escape into the air as a vapor. Now, what if we want to speed this whole process up? Can we? Absolutely. There are 4 key things that can basically hit the fast-forward button on evaporation. Let's dive into what they are. First up is surface area. Remember how we said evaporation only happens at the surface? Well, the more surface you expose, the faster it goes. It's pure logic. This is exactly why you spread a wet towel out to dry, instead of just leaving it in a crumpled ball. More surface area means more particles have a shot at that great escape. It's like having 100 exit doors instead of just one.
Next, and this one's pretty obvious, is temperature. Turning up the heat is like giving those water particles an energy drink. They start moving faster and faster, and way more of them have enough energy to break free. It's why a puddle on the pavement disappears so much quicker on a hot sunny day than on a cool cloudy one.
All right, factor number 3, wind speed. Why do your clothes dry super fast on a windy day? Well, think about it. As water particles evaporate, they kind of just hang out in the air right above the liquid. The wind comes along and whoosh, it sweeps those particles away, making space for more to escape. It's constantly clearing the launch pad, so to speak. And our last factor is humidity. Now, humidity is basically a measure of how much water vapor is already in the air. So let's think of the air as a big school bus. On a dry day, the bus is empty. There are tons of open seats, so evaporating water particles can jump on board no problem. But on a really humid day, that bus is already packed full. There's just no room for more passengers, so evaporation slows right down. Okay, so we know how evaporation happens, but let's talk about something really cool that it does. Have you ever wondered why you feel so chilly when you get out of a swimming pool, especially if there's a breeze? That shivering feeling? That's all because of evaporation. This is what we call the cooling effect. See, for those little particles to make their escape, they need a final boost of energy. And where do they get it? They basically steal it. They absorb heat energy from whatever surface they're on, your skin, a puddle, anything. And when they fly off into the air, they take that heat with them. So what's left behind? A cooler surface. And this isn't just some weird science fact. We see this cooling trick in action all over the place in our everyday lives. Let me show you a few examples. First, if you've ever used nail polish remover, which has acetone in it, you know what I'm talking about. The second it touches your skin, it feels freezing. That's because acetone evaporates incredibly fast. Its particles are literally robbing heat from your hand to make their getaway, which is why your skin feels so cold. Or how about this? Why do people always say to wear cotton in the summer? Well, when we get hot, we sweat. Cotton is great at soaking up that sweat. And then what happens? The sweat evaporates right off the fabric, and in the process, it pulls a bunch of heat away from your body. It's nature's own air conditioning. And here's a really clever one. In many parts of the world, people keep water cool in earthen clay pots, sometimes called a Matka. These pots have microscopic pores, tiny little holes, that let a small amount of water seep to the outer surface. That water then evaporates, constantly pulling heat away from the pot and the water inside. How cool is that? Refrigeration with zero electricity. All right, so we have a pretty good handle on solids, liquids, and gases now. We know how they change and how evaporation works. But do you think that's the whole story? Are those the only 3 states of matter out there in the universe? Well, spoiler alert, not even close. Say hello to the 4th state of matter, plasma. Now, plasma is what happens when you take a gas and you blast it with so much energy that it becomes, well, super excited and supercharged. It's basically an ionized gas that glows. Where can you find it? Oh, just in neon signs, lightning bolts, and pretty much every star in the sky, including our sun. And if we can go super hot, what about super cold? That brings us to the 5th state of matter, the Bose-Einstein Condensate, or BEC. This is the polar opposite of plasma. To make it, scientists, inspired by the work of Satyendranath Bose and the one and only Albert Einstein, take a gas and cool it down to temperatures just a tiny, tiny fraction of a degree above absolute zero. That's colder than deep space. So from a puddle drying on the sidewalk all the way to the fiery plasma of the sun and the deep freeze of a BEC, matter is way more complex than we thought. We've seen that temperature and pressure are like cheat codes that can change its state. But that just leaves one last question, doesn't it? What other forces are out there, hiding in the universe, that can unlock even more bizarre states of matter that we can't even imagine yet?